Okay, in this video, we're going to look at gear ratio, how to calculate that. We're also going to look at how to calculate the output speed or the speed of the driven gear in a system as well. Okay, so we'll look at the gear ratio first. Okay, so in this example here, we have a driver gear with 10 teeth and a driven gear with 20 teeth. Okay, and that gives us a reduction of 2:1. Okay, whereby the driver gear is going twice as fast as the driven gear. Okay, yeah, so that's called a reduction in speed. Okay, so yeah, and here's the formula here: it's driven gear over driver gear equals 20/10 equals 2/1 equals a ratio of 2:1. Gear reduction. Now we'll have a look at that in our in our gear generator here, whereby here is our driver gear. Okay, with 10 teeth. Just double check that, yeah. Driver gear, 10 teeth here. And here is our driven gear, okay. And that one there has 20 teeth, okay. So, yeah, so let's just run that there. Yeah, and we can see our driver gear. This is the one that would be attached to the spindle of a motor. Is spinning around there, 10 teeth, 10 teeth. And our output gear, now every other gear attached to our driver gear is going to be driven. Okay, so that's part of our output system. And that has 20 teeth. And we can clearly see that it's going a lot slower. Okay, there we go. So that's a ratio of 2:1. 2 rotations to 1 rotation. Okay, so if this one here was, if this driver gear was going 100 revs per minute, this driven gear here would be going around at half that speed, 50 revs per minute. Okay, now let's have a look at the other question here, sorry. Looking at working out the speed of the output gear. So for this one, we need the speed of our input or our driver, all right? So our motor gear, the driver, has 36 teeth and revolves 100 revs per minute. All right, 36 teeth, rotates 100 revs per minute. And the driven gear has 12 teeth. Okay, how fast is it rotating? Or what's its RPM? Okay, it's smaller, all right, than our driver one. All right, it's 3 times smaller. All right, so we can, even before we do the calculations, we know that if it's smaller, it's going to be rotating faster, okay? And our answer is going to be 300. 12 goes into 36 3 times. All right, this is our formula here. Here's our proof. So our speed of our driver times the number of teeth of our driver divided by the number of teeth of our driven gear, okay? Gives us 100 multiplied by 36/12. All right, 100 multiplied by 3/1, which gives us 300 revs per minute. So our driven gear is going 3 times faster, 300 revs per minute. Let's have a look at that in our gear generator. So this time it was, sorry, oh yeah, 100 revs per minute. And our driver gear this time had 36 teeth. It's the wrong one. This one here, 100 revs per minute, 36 teeth. Okay. This is our driven one, and our driven gear had 12 teeth. More like it. So this is what that system looks like. All right, this gear train, all right, driver gear, 36 teeth, driven gear here, 12 teeth. Let's have a look at it. Okay, there it goes. So we can see here that our driver gear, okay, is rotating a lot slower than our driven gear, okay. 3:1 speed increase here, okay. So this one's rotating at 100 revs per minute, and our driven gear is rotating at 300 revs per minute. Okay. Okay, so let's have a look at these here in tinkercad and try to apply what we've learned to tinkercad now. So this one here, well, all right. So first of all, sorry, we can bring in gears over here, okay, into tinkercad. It's really easy, okay. You just go to your shapes, go down to shape generator all, okay, and on the third page you got gears, okay. You just drag them out as normal, all right, just like so. So that's our useful gear I just brought out. It comes with a hole for the shaft there on it already. It's a bit of a simpler looking gear, but it's fine. All right, this is the metric gear here in blue, and as we can see, the teeth are pretty accurate looking. Okay, doesn't come with a central hole, but you could easily find that for whatever size shaft you want to use. Okay, and yeah, so this one here has this driver gear here has 10 teeth. Okay, and this one here is our driven gear has 20 teeth. Okay, so this here is kind of like our first system here. Sorry. The driver has 10 teeth and the driven gear has 20 teeth. The speed reduction, okay? Gear ratio 2:1, speed reduction 2:1. So if this one is stuck to the motor and it's going around, it'll do 2 rotations for every 1 rotation of this one here. Okay, so that's a speed reduction there. And then we can machine off these, on the laser cutter. You can get your own speeds and feeds, or sorry, just calculate your own output speeds for your project. If the gears we have don't suit you. And we'll also have a look at the other gear system, okay, which was calculating the output speed. All right, now. So I'm just going to use the useful gear for this one here. And in this one, we had a driver gear of 36 teeth and a driven gear of 12. Okay, so I'm going to change these now. So we'll call this the driver. 36. Okay, I'll move that over here. And this one at 12. Yeah, okay. And sure, we'll just line them up there so it looks like they're meshing nicely. Like that's the way it would be in a project. All right. And there we have 2 gears ready to be cut out if you wanted to have a speed increase. Okay, so this one here, the driver gear, will be attached to our motor. Okay, and if we wanted our output to be traveling much faster, we'd have this smaller gear here, and that would be our output. So this would be for something like the seed spreader project from Junior Cert 2 years ago, I think. Okay, whereby you cranked the handle with your hand, and that was driving the gear. So that gear was a big gear, and it was meshing off a small gear in order to get good velocity and fire out grain and seed out really fast. Okay, so so these gears can be manipulated and shaped to whatever requirements that you want for your projects. Which is very, very, very useful. Now, yep. So there you go.